Hello everybody, your professor Anindya Paul, completing the control section structure. So we had left off our first part of the recording where we looked at the switch statement. So let me just go back just for reference purposes. This is how we wrote our switch statement, and in the switch statement, an important or integral part of the switch statement is this break statement. And what this break does is, when we are evaluating the condition, if it meets the first condition, then it allows us to come out of the entire switch statement. So this break statement actually increases the or optimizes the switch statement, allowing us to break out as soon as the condition is met. It does not let you go through the entire statement. So if I choose my first condition, and if it's a false condition, it will go to the second one. If the second one comes out to be true, it would immediately break without having us to go through the case number 7, 6, or the default case. So this is very important, and this is what is been referred to over here, that the break statement is very, very important here, and it optimizes the running of the program, because if I come across a lengthy switch statement, the break statement would allow us to break out of that loop. So continuing on, we also have a default. So if I am writing my switch statement with 3 or 4 condition, anything other than that would be caught under the default section. So continuing on, this is how I can create a UML diagram for my switch statements. So these are my case A, B, C, and continuing on, and the last one is our default statement. Of course, just like you had seen before, you have case scenarios, and then it will go inside the case scenarios, and it will, if it is true, then it will get inside the case, and then it will break out. Otherwise, it would just continue. This is important right over here. When you are using your switch statement, be very careful about the quotation. When I am using my character constants, it is using a single quote such as A7 or $sign over here, which represent an integer value character. So this is very, very important. You also would see something like an enum type. So sometimes this allows us to create our own variable. So just wanted to point that out, because you might see something with the enum. We are coming back to our objects, the classes and objects. So here what we are doing is basically writing a program where we would use a class object relationship. Okay, so let's take a look, and this is basically the problem that you're trying to solve. So here what you're doing is your application requirements is that you're writing a program. You have been hired by an auto insurance company that serves these northeast states. So these are the states that are included. The company would like you to create a program that produces a report indicating for each of their auto insurance policies whether the policy is held in a state with no fault auto insurance or not. Okay, so these are some of the things that we would use. So these are my class, which is my auto policy, and then I would create my account number, and then I would create my string instance variables like this. So let's take a look at the program, and this is something that we have seen before. So here I start off with a public class auto policy. Now notice over here it does not have a main method, because I do not want this to be it can be compiled, but I do not want this to be running or ran, because it cannot run because it does not find the main method. So this is just the class or the blueprint that I'm creating, and I have some instance variables, and these are all private variables. So I have an account number, I have a string make and model, a string state, and then I have some constructor. The first constructor is my auto policy. This is the constructor because it has the same name as the class, and it has this signature where it will take in 3 parameters, 1 integer and 2 strings. So 1 string and 2 string. Okay, and of course I'm using these account number, make and model, that the values that I'm getting through my auto policy constructor, the values that I'm getting now, I'm using those values that I'm getting to set my default as my account number, my make and model, and my state. Now I'm also creating some set and get values. Now remember, I had shown you in a program earlier, by the use of either NetBeans or Eclipse, you can create as many of the set get values defined by your instance variable. So you can easily use that feature and it will create these values for you. So your set account number, remember, this is always going to be void because you're not returning anything, and again it's going to take in an integer value. The value that you take in is now going to be used to set that account number. Continuing on, you have your get account number, which is just returning the value. Similarly, you're going to create your set make model and get make model. So these are all set get values. So you continue with your set get values, and I'm not going to repeat them anymore because we have gone through this before. And then I write this method called is no fault state. Remember, this is the name of the method. It is completely up to you. It is returning a boolean, which is going to return either a true or a false. So first off, I'm going to start off with a boolean no fault state. Okay, so at this point, this is just my boolean value, and I'm using my switch statement. So get state is the method, and my cases are MA, NJ, New York. So these are all my cases where my value is going to be true, and if it is one of these states, then it is going to break out of this switch statement. But if they're not, then the no fault state is set to false, and again I'm going to break over here. So now these are the methods and the variables that we have defined. Now I'm going to create an auto policy test. Okay, this is where I would create my object. So here, this is my object. So I have my public class auto policy test. So there's my class, and this is where I would define my main method. So this is always my test class that I'm writing, where I can create my objects, policy 1, policy 2, policy 3, which is going to be using the blueprint of auto policy that I have defined before. So these are my blueprint class of auto policy. Okay, so now I start off with auto policy. This is the blueprint, the class that I had just defined earlier. Policy 1 is an object of that type, my keyword new auto policy. And if you go back to the constructor over here, you will see that this is the constructor which has this which has this signature. It is taking an integer value and 2 string values. Okay, so when I create this policy 1 and pass these values over here, it gets set into the instance variables which are defined as private right here. Okay, so here is my auto policy 1, policy 2, and then I call in this method called policy is no fault state and pass these objects policy 1 and policy 2. Now again, if I go back to this policy state over here, remember this no fault state, and the no fault state is going to return a boolean value, and then I have this get state values, and if I am passing any of these values, then it is going to be true, otherwise it is false. So right here, when I call this policy is no fault at state, no fault state, policy 1, policy 2, it comes up and says, okay, here is my new method that I have defined. So this is a void method, policy is no fault state, and it's passing an object of the type auto policy. Okay, So policy is just the object name that I'm defining over here, and then I have a system out print line. The auto policy is, and this is my printf with my default printf method, which shows account is this, my car is this, and if it's a no fault or a yes fault. And then I'm calling this policy.get account number, policy.get make and model, policy.get state, and then I'm using this method over here to display the value. So basically this is the condition, and if it is true, then it selects is. If it is false, then it selects this. Okay, remember this is a void, so it does not return anything. So it just says state nj is a no fault state. So I'm going to say whatever the state is that I'm taking the value in is, if it is true, it is. If it is false, it is not. Okay, so that's how I'm using this, and that's how I'm getting these values over here. This is a program where I'm using a break statement. Now this is kind of outside. This is a completely separate program. We finished our policy, our class and object. This is a completely different program which shows you how you can use your break and continue statement. So this is a break test. That's the name of the class, public static void main, and I have my counter and count less than equals 10. So what it's showing you is when you are running a for loop and your condition over here has to be true, but inside that you have a condition statement, and if the condition is equal to 5, so between your statement, between your values from 1 all the way to less than equals 10, if this condition matches, then it would break out of the loop. Okay, so that's why it breaks out of the loop, and then it says, okay, system out printf count, and it says, okay, broke out of the loop at this particular count. So I would get 1 2 3 4, and as soon as it hit 5, it is going to break out, and then it's going to catch the statement broke out of the loop count at this. Okay, so the system out print is actually printing you 1 2 3 4, but then when you're coming out, when you're catching this one, that's when you're actually coming out, broke out of the loop at counter number 5. Okay, just like your break, you actually have a continue. So what it does is when you come to that continue, this is going to just skip. So as you can see, starting with a count, your condition is less than equal to 10, but within my for or repetition, as soon as I come to my count equals 5, I would continue. Basically it is going to skip that 5 and then continue on to your loop again. So that's why you get 1 2 3 4. As soon as it hits 5, it would skip and then continue on to 6 7 8 9 and 10, but then used to continue to skip printing at 5. So this is where you are actually capturing the value that you used to skip out. All right, continuing on, you have your AND and OR. Again, very important thing, logical operators that you were going to come across. So you have the different kinds, AND, OR, Boolean logical inclusive or logical exclusive OR. Sometimes you would see them. And this is basically when you have an AND, both expression has to be true. So when you have a condition has to be false and true, it is false. If it's true and false, it's also false. So both condition, expression 1 and 2 has to be true. So it's either both of them are true or both of them are true or both of them are false. You cannot catch any of these. Whereas when you have an OR, you are actually going to see that these conditions are going to be okay. So this is my OR condition, and this is where, of course, either one could be false or both of them could be false. So that's why you get this. And sometimes you would also see this OR exclusive right over here, and this is exactly telling you, so this is an OR, so very similar to the OR condition that you have seen before. And that's why I'm not going to spend too much time. You are also going to see sometimes people use this not equals. So as soon as you become not equals, it just reverses the condition. So a false expression becomes true, a true expression becomes false. So that kind of reverses the condition. Okay. This is again your format specifier. I'm not going to spend too much time here. And this is an example program. Again, it's pretty simple to follow. Basically, checking to see which conditions are AND conditions and which conditions are OR conditions. So if you look at the output over here, these are your conditional ANDs, conditional OR, and then Boolean logical AND. Okay. This is very important. These are your logical operators. You're going to be using this thing all the time. You have already seen the use of this conditional statement right here in a previous program that we just went over. So that's your structured program summary. We can also use UML activities to create this selection. So you have an if selection, you have a switch selection, you have an if else, and this is something that we have seen before. Okay, more of the repetition through the UML diagram. So this is your while statement, do while, and for statement. The last part we'll talk about is the FXML. This is the part where in chapter 3 we had introduced how you can use the gluon to draw some of those shapes, but this is actually showing you the code that gets created at the back end. And this is the one where you have to write a controller, and this controller is going to control the program. So this controller that you see over here is using, so this is my public class draw shape controller. It is using these methods that I have, and the methods are actually passing an action event. This is something that we will talk about later in the chapter, but this kind of introduces some of these things. And at this point, the only thing that I would like for you to do is, if you want to try these things on, the program code is written in the book. Try to follow and see if you can get it to work. So in this example over here, this is your controller, this is your first method, and then you have your second method that you have created, and then you have to write your draw method, and within your draw method, these are the steps that you have included. And you actually are using a for statement and also a switch statement. So basically, depending upon the button that you choose, it is going to create a stroke rectangle, or if you choose the oval button, it's going to create the stroke oval. So this is what it's going to look like. So this is how the GUI is going to be looking. If this is an active button, if your program is written correctly, this is an active button, and if you click on it, this is how the rectangles are going to be created. And I think if I remember it correctly, you have 10, so basically you should get about 10 rectangles if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, yes. And then the same thing with the oval. So it is really the shape that gets created when you press each of these buttons, okay? And then it gives you that you can also change those methods, and should give you draw circles and squares, and in this one it's draw circles. So that kind of completes the control structure, and we will continue on with methods for the upcoming chapter, but this is something that you will be using, and you have already seen the use of this control structure in our other languages, but we need to make sure that you can write the Java syntaxes for using this control structure. Good luck.